Mainstream physics describes the human mind as a strictly local phenomenon. The consensus is that your consciousness consists of electrical noise trapped inside the skull, a biological byproduct that cannot reach out to manipulate the physical world. But at Princeton University, psychologist Roger Nelson and a team of engineers spent decades testing a different hypothesis. They operated out of the engineering department to see if human intention could exert a direct, measurable influence on physical reality. They used devices called random event generators, or REGs. These function like high-speed quantum coin flippers. Inside the machine, electrons are pushed against an energy barrier. Occasionally, due to a phenomenon called quantum tunneling, an electron appears on the other side. Each time it does, the machine records a 1. If it doesn't, it records a 0. Because this relies on quantum mechanics, the outcome is fundamentally unpredictable. Even the electrons do not have a determined path until the event occurs. The result is a stream of data that is, by every known law of physics, perfectly random. This high-sensitivity randomness provided Nelson with a blank canvas. If human consciousness possessed any physical influence, these undetermined quantum events were the most likely place to see it. In the early trials, a participant would sit near the REG and simply focus their mind on a goal, such as forcing the machine to produce more 1s than 0s. There was no physical contact and no wiring, just the internal effort of the subject. This chart shows the results across millions of trials. While the deviation in any single moment was tiny, the cumulative data showed the machine drifting away from its 50-50 baseline in the direction the subject intended. In some series, the probability of this happening by chance was calculated at 1 in a billion. The anomaly persisted even when the researchers increased the separation. When participants were hundreds of miles away, or even when they focused on a machine a day before it actually ran, the data showed the same statistical shift. The effect did not decay with distance or time, which is not how we expect a physical force to behave. These individual effects were microscopic. You won't be using your mind to change the TV channel, but it raised a much larger question. If a single mind can create a measurable shift in quantum probability, what happens when millions of people focus on the same thing at once? The researchers eventually scaled the experiment by shrinking the REGs to the size of a laptop and taking them out of the lab. They wanted to see how the machines would react to the shared experiences of large groups. One study took place at Devil's Tower in Wyoming. A Shoshone shaman led a group in a healing ritual, and as the participants entered a state of shared attention and drumming, the REG data recorded a dramatic spike in organization, deviating sharply from the random baseline. Nelson attributed this to coherence. The machines seemed to be responding to the fact that the group's attention and emotions were unified by the ceremony. This contrasted with data from major sporting events. Even with tens of thousands of people feeling intense emotions, the machines typically showed no effect. In a stadium, half the crowd wants one team to win, while the other half wants them to lose. Their intentions conflict, creating what the researchers called interference. These field results suggest a pattern. The measurable footprint on the REG only appears when individual minds align. For the researchers, it pointed to a specific requirement for this effect: shared, unified focus. This led to the Global Consciousness Project. Nelson set up a network of about 70 REG nodes around the world that run continuously. The goal is to see if global events that capture the world's attention leave a mark on this synchronized stream of randomness. A consistent example occurs every New Year's Eve. As the world celebrates, the network records a predictable drop in randomness. The variance among the independent machines decreases as humanity focuses on the stroke of midnight. But the project's most significant data spike occurred on September 11, 2001. As the terrorist attacks unfolded, the global network registered the largest anomaly in its history. This timeline charts that data. The most striking detail isn't the reaction during the attacks, but what happened before. The network of machines began to deviate from randomness 4 hours before the first plane hit the World Trade Center. Mainstream science remains skeptical of these results. Critics point out that the effect sizes are so small they could be the result of statistical noise, or that the researchers may be unintentionally selecting only the events that fit their hypothesis. Nelson argues that the patterns are too specific to be noise. In the 9/11 data, for example, the machines in Brazil and Europe reacted more strongly than those in the US, which challenges a simple model of physical proximity. Additionally, the data curves often resemble the shape of human brainwave responses. Even with these valid scientific critiques, the consistency of the 9/11 anomaly suggests a need to reevaluate how human minds might be interconnected on a global scale. To explain these results, Nelson points to the work of physicist David Bohm. Bohm theorized a hidden, implicate order to the universe, where consciousness acts as a source of information that helps provide structure to otherwise undetermined physical systems. This idea aligns with the evolutionary philosophy of Teilhard de Chardin, who proposed that humanity is developing a noosphere, a layer of collective thought surrounding the Earth. He used the analogy of the brain. Just as billions of individual neurons unknowingly collaborate to create a single human consciousness, the minds of 8 billion people might function like the neurons of a developing planetary intelligence. While a literal global superconsciousness remains a hypothesis, the data from the Princeton lab suggests that consciousness might play a more active role in reality than a purely biological model allows. If these findings are accurate, they suggest that the isolation we feel is an illusion. Whether we are part of a larger superorganism or just a deeply connected network, our minds are not as private as we assume. The field experiments showed that conflicting intentions created static, while unified attention created order. This implies that the state of our collective focus has a tangible effect on the environment we share. It means that our individual thoughts, our deepest personal anxieties, and our collective intentions are constantly contributing to a shared background, helping to shape the physical noise of the planet. If consciousness truly influences the physical world, then human empathy and shared attention take on a new significance. Beyond their value as social virtues, they appear to be the necessary conditions for moving a system from random noise toward a unified direction.